Hey everyone, this is lesson 512, multiple representations of quadratic functions. So this is a continuation of most of the chapter on quadratic functions. This lesson actually kind of summarizes a lot of what we're going to be doing for the rest of the chapter, and it kind of carries over into other chapters later in the book and even into the next course. So most of you kind of have already an idea of multiple representations of functions. So probably at this point you've seen linear functions from a previous course, and you've seen them written in different ways. And so what we're going to do is kind of review that, except we're going to focus on quadratic functions in this lesson, in this chapter. So our goal is to kind of understand this, I guess, flow of representing quadratic functions. So let me explain that. So normally we see when we talk about equations, that's something that we all understand, whether it's linear, quadratic, and so a lot of times we'll take an equation and we'll graph it, right? So we'll take an equation and see what that graph might look like. Or maybe you'll get a table of points, and from that table of points, you might turn it into a graph. And then maybe you have a graph and you say, you know what, I want to know what the equation is of that, and check to see, is that the right equation? Is it something else? And so there's this connection between how we represent our function, no matter what kind of function it is. Do we want it as an equation, something maybe we could do calculations with, use some algebra skills, or do we want a picture of what it might look like? And does that help us understand the function better? Or maybe we want to organize that information a little bit differently so that we could maybe easily find certain points that we're looking for. In addition to that is the situation, or sometimes I'll call this a description. So sometimes we want not an equation, not a table, not a graph, but we just want some words that describe what's going on. So sometimes it might be in the form of a story, context. In this case, it says Al releases the balloon from 10 yards away. So it's telling you some information that is key to maybe what the graph might look like. Or maybe there's just more specifics of what the x-intercept is or what the y-intercept is, little details about the graph that someone could take and maybe create the graph, or maybe even take that same information and write an equation. And technically you should be able to I could give you any one of these, and you'll notice all these arrows going pretty much every direction. So you should be able to take any piece of information and write it in any other representation. So that's an example of what we're trying to do. This is just a visual of the big picture. And so I'm going to focus on, I'm just going to do a couple problems here. And so what I want us to try to do is see all these things together. And so for the most part, we have to be given something. And so what I want us to start with is an equation, because that's kind of might be the easiest for some of us. And so I've started us off with this equation, y equals x squared minus 6x plus 5. And I want to see if I could represent it using a table, a graph, and maybe a situation. So I've started this for us. And I think a lot of times, once you have an equation, we don't necessarily know how to graph it. And so I'm going to kind of show you how you could graph this without using a graphing calculator, because I know some people have asked. The easiest is probably just to type it into a graphing calculator to give you a picture. But what that does, it kind of skips the table, which the table, even though sometimes people feel it's unnecessary, it actually gives us an easy way to find information. So everything here has value for sure. All right, so what I'm going to do is I'm going to focus on the first part. And so I'm going to focus on creating a table using the equation. And the way we do that is, well, one, you'll notice I've created a table, and I started this for us already. And you need to make a decision on what x values you're going to use. I've started off with -1. For the most part, it's always nice to have some negative numbers, 0, some positive numbers. Because I already know what this graph might look like, I've started us off on -1 to see. So just so you know where that lands. And the way we find, we're going to plug in these x values. So I chose this number, right? You could choose any number to start with. I'm trying to choose numbers that I know are going to fit on my graph. So -1 is the one I decided to start with. When I plug in -1, you'll notice all this work that I've already started for us. Really, it just looks like the original equation. It is the original equation, except I'm replacing all these x's with this x. So this is what we call evaluating. So I'm going to plug in a -1. You'll notice I have parentheses as well. It will change your answer if you do not put parentheses. So be careful here. I've also written these out in a way where you could, if you type this into a calculator, like a Desmos calculator, scientific calculator, something where you could actually see all the stuff you're typing. It's a lot easier than trying to do this even in your head. So I would include the parentheses. They're there for a reason. Trust me, it's worth the time it takes you to put those in. So if I multiply all this out and I subtract and add, this is going to give us 12. All right, so if I plug in a -1, it's going to give me 12. If I plug in a 0 instead, it's going to give me a 5, which makes sense. 0 squared is 0. 6 times 0 is 0. So this is really 0 minus 0 plus 5, which means it's going to equal to 5. All right, so there is a way, some of these might be easy enough you could do in your head. Otherwise, it doesn't hurt just to type these in the calculator. And so as I plug in all these numbers, you will notice it'll end up giving you different y values, which I've started to fill in for us. So again, make sure when you're copying this down in your notes, definitely include, if you don't want to write all these out, that's fine. I would at least encourage you to write a few of these out, just so you know how these y values came about. All right, so because a lot of times when people don't write this stuff and then later on they look at their notes, they're like, I don't even know where these numbers came from. So definitely I would recommend showing your work here. That way you have a record of how those numbers appeared in the y column. All right, so as I plug in numbers, you should notice, like when I plug in a 4, I believe this, you know what, I'll hold off on the table for right now, just so I could hold off on telling you something else. So let's say I just stop right there on the table and we say, okay, well now I have a table of points. What good does that do me? Well, there's going to be some key points here that are going to be meaningful to us, and I'm going to start with probably maybe this one and this one. If you notice these that I've highlighted, these are the ones that have zeros. All right, so that's going to mean something to us a little bit later. And so let's say we're at the point where we want to see what the graph looks like. Again, we're not using a graphic calculator here. Our way of doing that is just plotting these points. Now we have a collection of points we could plot. So you have to think of these as coordinates. So -1, 12, 0, 5, and 1, 0. Right? So these are all points. These are all points you should be able to plot. And so let me switch over a little bit. And so I'm going to plot these points. Well, -1 is over here. 12 is way too high. So that one doesn't fit on my graph. But 0, 5 does. So I'm going to put 0, 0, 5. Right? If you draw your graph big enough, you might be able to plot -1, 12. So it's up to you. I think this one should be fine for now. And so I have 0, 5, and then I have 1, 0. 1, 0 is going to be right here. And 2, -3. 2, -3 is right here. All right, it starts, it pretty much looks like it's kind of a straight line. And then we do 3, -4. 3, -4, which now it starts like it's not looking like a straight line. It's starting to curve a little bit. And so the question is, well, if it's starting to, I thought it was a straight line, but then it starts to curve. Remember, we're graphing quadratics. Quadratics are not straight lines. So that means you'll notice something else is happening after this point, and I don't know what it is. This is why it's important to keep going on the table. So if I finish my table, it's actually going to give me, if I plug in a 4, it's going to give me a -3. Right? And so that's going to be 4, -3 is right here. And you could see in the graph, as it comes, it's starting to curve, right? It starts to curve back up. And so the nice part about quadratic functions, these parabolas, is they are symmetrical, which means there's going to be some line of symmetry. There's going to be some line of symmetry that appears. Let's see if I could draw that in. So I believe it's going to be somewhere around here. See if you can see that line. So that means the left side and the right side are going to be mirror images of each other. So you'll notice these two are mirror images apart, which means there has to be another point over here to match this one. And then the same thing over here. This is 3 away. This is going to be 3 away. So sometimes without even plugging numbers into the table, I already know that I'm going to have these other points, only because they are mirror images of each other. Right? So that's a nice part about understanding lines of symmetry. So if I was finishing my table, that would be 5, 0. Oops, let me change the color there. 5, 0, and then I think this is 6, 5. And so you should notice now what that does, it also gives me another point with a 0 on it. So those points were here and here, and that other point, 0, 5 was here. All right, so if you haven't noticed, what I've highlighted are my x-intercepts and my y-intercept. So you'll notice those are also in your table. All right, so the last thing to do is to sketch a picture of this. And so let's see if I could do a decent job of this sketch. And so I'm going to go something like this. Oops, that doesn't look good. It's too much. I don't need it to be. Oh man. Oh, I know why it's doing that. So I'm going to go through these points, and I'm going to go through these points, something like that. A little squiggly, but I think it gives you a good idea of the picture of that parabola. All right, so we have a good number of points. 1, 2, 3, 4, 5, 6, 7 points that we're able to graph. All right, so the last part is, what's the situation? Let's describe this graph. So we've done this in a previous lesson. Some things to kind of make note of. Maybe the orientation. Is this positive or is this negative? Is it facing upward? Is it up or is it down? So this would be an example of a positive graph, right? Because it's facing up. What else were we looking for? Let's see. Vertex. Let's see. Do we have a vertex? Where is it? Let's see. Vertex is going to be, let me highlight that one a different color. So vertex is going to be at the bottom. So we just need the coordinates for this one. Let's see. What is that? 3. This is the vertex. So this is going to be at 3, -4. And so you should notice also that is 3, -4 is in our table as well. All right. So x, our intercepts. We have x-intercepts at 1, 0, and 5, 0. Right? Actually, right now, all I did was I looked at our table. I didn't even look at the graph. And then y-intercepts would be this one. So I'm going to look here, and that's 0, 5. So 0, 5. All right, so it's a lot of information. And then the other thing was, I think line of symmetry was nice to know. Line of symmetry. And that's going to be x equals 2. And then that's this line that I drew in. And so it's always going to be the line that goes through the vertex. And so that was at 1, 2, 3. So this is going to be x equals to 3. All right, so that's an example of, really, we look at all this information that we went over. There's an equation given to us. We plugged in a bunch of numbers. We have a table that has a lot of answers. We have a picture of what it looks like. And we have a description of what all the key things about that graph. So that's ideally what you need to be able to do. And so I'm going to see if I could, hopefully this one doesn't take as long. The next one I'm going to go through, I'm going to have us start with the graph. So we don't have to worry about graphing this. This one might be a little bit easier. And so I've started us off with this graph. And so if you have the graph, can you kind of work backwards and get all the key information out of that graph? And so the first thing that I like to do is just find all those key points. Any points that are very obvious from the graph would be nice to maybe mark on the graph. And so I'll start with, I'll zoom into this graph for a second. I'll start with maybe like the vertex, right? I know the vertex is at the bottom here. I'm looking at some other key points that it kind of goes through that maybe are a little bit obvious. And maybe I think these as well. And so now I've just gone through and made them very clear. So I have 1, 2, 3, 4, 5, 6, 7 points. And so at the very least, you should have probably 5 points. These 5 points are usually key points. Above that, it just depends on how much room you have. Excuse me. So we just need to know what those points are. What I'm going to also do is maybe highlight which ones are key points. So I have my vertex. I have my y-intercept is there. I think that's it. And then I also noticed that this is also my vertex. So 2 colors on that one. That's a little confusing. All right, so I'm just going to list these out. So I need my x values. So if I always start left to right, And so this is going to be, this point's going to be at -2. So -2, -1, 0. So I'm going to start by writing those out. -2, -1, 0, 1, 2, 3, and then maybe I'll just add 4 to that. Make my table a little bit bigger. All right, so you'll notice we don't have to plug any numbers here. All we're doing is copying from the graph. And so now for this first point up at the top, this is going to be at 9. Right, so I'm going to put 9. And then the second point, this is going to be at 4. So 4. And then this one, 0 is at 1. And then at 1, we're at 0. And so the nice part is, because we have this line of symmetry, all right, 1, 0 was 0, 1, oops, it was the other way, 0, 1, and all right, so we have this line of symmetry, and I'll draw that in as well, just like I did last time. And so that one's going to go through the vertex about there. And so you should notice, just like on the graph, you should notice a pattern with the points. So the points will repeat. So now instead of doing 9, 4, 9, 4, 1, 0, it's going to go 1, 4, 9. And so that's the nice part about parabolas. You should see that. So without even looking, I already know that pattern. All right. And so describing this graph, we'll go through kind of the same things as before. What's the orientation? Is this going to be positive or negative? Well, this one's also positive. Kind of try to make these easier, which means it's facing up. We have vertex. So do we have a vertex? This is going to be at 1, 0. Right, this was the vertex at the bottom. And do we have any intercepts? So x-intercept is going to be at also at 1, 0. There's only one intercept here. You'll notice that it's only crossing the x-axis once. It's not like another graph where it might cross twice. It's only crossing once. And so that's okay. And then y-intercept, this one is at 0, 1. So 0, 1. All right. And so the last thing was the line of symmetry. Line of symmetry. And that one's going to be x equals 2, 1. That one's x equals to 1. How do I know that? Because that's this line. It goes through 1 on the x-axis. All right. And that's pretty much it. So really the question is, what's the equation of this? So we have everything except the equation. That is, oops, let me write it like this. To be determined. All right, so we don't know yet. And so that's what the next lesson is going to start focusing on is, well, if we have all this information, can we figure out what the equation is? And we're going to try to find easier ways to work with the equation based off of this information. All right, I'll stop there with that example. Those two are pretty good examples to have in your notes. Let me know if you have any questions about any of this, and hopefully this will make more sense in the next few lessons the more we practice doing all of this. All right, thank you very much.